It's me again, back here at Common Core Algebra II. Today's lesson is Unit 12, Lesson 2 on sets and probability. So since the basic calculation within probability involves counting the number of outcomes that fit into a particular event, it makes sense to have a tool to visualize and keep track of all of the outcomes in a sample space. We do this by using sets. So recall the basic definition of a set. A set is simply a collection of things, numbers, objects, or etc., that satisfy a well-defined criteria. That the things that are contained in a set are called the elements of a set. And just remember that when we talk about a set, we talk about set brackets. All right, sometimes I call them squiggly brackets, but they're called set brackets. All right, if you can't make those, you can simply just squiggle on both sides, and we understand that that means a set bracket. Okay? So, exercise 1. The set A is defined as the collection of all integers that are greater than 0 and less than 10. So, remember we're using our active reading strategies. So, the set A is defined as the collection of all integers that are greater than 0 and less than 10. So, make sure that when you're doing this, you're thinking about what is an integer. Integers are all numbers that fall on our number line that you actually write or represent on the number line. So the numbers like 0, 1, 2, -1, -2, and so on in both directions, to the negative and to the positive. And numbers that are greater than 0 means we don't include 0. So we're going to say set A equals 1, 2, 3, 4, 5, 6, 7, 8, 9, and not 10 because it says less than 10. It doesn't say if it said between 0 and 10 inclusive, that means you'd include the 0 and the 10. So B says show a set diagram show set A in a Venn diagram form. So this is a pretty ridiculous little Venn diagram because basically it's simply just going to be one circle with all of our numbers in it. 1, 2, 3, 4, 5, 6, 7, 8, and 9. A subset is any set whose elements are contained within the other set. Give two possible rules that could define subsets of A, and then write the sets as B and C in roster form. Now, roster form means that we're going to write it like a basketball roster, like you're going to write all the terms out. So do sets B and C have any elements in common? So because we can choose what we want, I'm just going to choose, let's say we let the set of B be odd integers, right? So odd, we can even say odd numbers because we're talking about the set A where we have our integers already. So so B is going to look like, what are the odd numbers from our set A? Numbers 1, 3, 5, 7, and 9. All right, so let's pick a definition for C, and let's pick prime numbers. They like to pick prime numbers because prime numbers are asking you two questions. It's asking you, do you know what a prime number is? And do you know what a set that contains prime numbers look like? Now, prime numbers basically always start with one number. And it starts with a very special number, and it's 2. Because 2 is the only even prime number, and it's also the first prime number. 1 is not a prime number, so if we remember that 2 is special because it's the first one and it's even, the rest of them come pretty easily. So we have 2, and then we have 3. Let's remind ourselves what a prime number is. It's all numbers that only have 1 in itself as factors. So we have 2, we have 3. We don't have any other even numbers now because they'll always have 2 as a factor. So we'll skip 4 and we'll go to 5. And we'll skip 6 and we'll go to 7. So it's looking like all odd numbers, but when we get to 9, 9 can be 3 times 3, so we skip that one. We skip 10, we go to 11. So these are basically so on and so forth. These are the list of prime numbers. So based upon our original set of A, 1 is not a prime number, 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, and like I just said, you skip 9. All right. So, and it says, do sets B and C have elements in common? Well, we can see that they have 3, 5, and 7 in common. Okay, so down here you can write sets B and C have the numbers 3, 5, and 7 in common. Exercise 2. Consider the experiment where we first toss a coin. So first we toss a coin, and then we note the outcome, and then we roll a 6-sided die, and we note the outcome. So A says, write a set of ordered pairs such as H, 4 representing heads and rolling a 4 that represents all outcomes for this experiment. Recall that this is called the sample space. We will generally call this set S. All right, so what is this going to look like? Me personally, I told you I'm more of a visual. So if I get my first experiment is I'm going to throw a heads or I'm going to throw a tails. All right, so then after I've done that, what's the next possibility? I can roll a 1, a 2, a 3, a 4, 5, and 6. And the same thing goes here. 1, 2, 3, 4, 5, and 6. So as I can see, I'm going to have 2 times 6, which is 12 outcomes. So that's how I can determine how many outcomes I have. So B says, write a set of ordered pairs that represent the event of getting a tail and an even number. Call this set A. So set A is going to be basically a tail and an even number. So which one of these has that situation? So A is going to be, remember I'm going to have ordered pairs here. So I'm going to have a tail, so it means I'm going to be over here somewhere. I'm going to be over here somewhere. So, and I need tail and an even number. So I'm going to have a tail and a 2, a tail and a 4, and a tail and a 6. So that's my A. C says the complement of set A will be all of the events in the sample space S that do not fall in set A. Write out the complement of set A. We'll call this set B. So set B is going to be all the other ones. And this is going to be a pretty big set because I have all of my heads. So I have all of this one to do and the few here that I didn't pick up with the even ones. So I'm going to have heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, and now I'm going to have tails 1, tails 3, tails 5. I know it seems weird, but you should have commas really between these as well. I don't think you'd lose any points for that, but it makes sense. All right, so now find the probability of A and the probability of B. Well, the probability of picking the situation in A is going to be the total number of outcomes in my denominator, which we said was 12. And how many A's do we have in our set? We have 3 of them. So this is the same as 1/4. And the probability of B is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 over 12, which is equal to 3/4. So I ask you before we move on too much is to recognize what this is right here. All right, because P of A is the probability of A happening, and P of B is going to be the probability of the complement happening. All right, sometimes we call the complement, if they ask us to find the complement, we say the complement of A prime, like this. And that means the complement. But most of the time I have to say in Common Core, they tend to use the words, find the complement of A, not necessarily using notation. So write down what you need to. We'll move on to exercise 3. So a set and its complement are important when we look at probability because all of the outcomes either fall into the event or into its complement, but never both. All right, so it's like the probability of picking a heads. Well, you can't, if you're going to do the complement of that, it's got to be the probability of picking a tails. It can't be something of picking, you can't have something that lies in both of those. So in exercise 3, consider rolling a 6-sided die and recording the result. Let set A be the event of rolling a number greater than 4. All right, let's underline that. Set A, number greater than 4, and set B is the complement of set A. So draw a Venn diagram that illustrates the sample space S and the sets A and B. So do we have an overlap is what we have to consider. So a Venn diagram talks about two sets. We'll call this set A, we'll call this set B. So set A is the numbers greater than 4. So we know that we have 1, 2, 3, and 4. And then we have find the probability, I'm sorry, and then set B is going to be the complement of set A. So B is going to be I'm sorry, I'm totally messing this up. I was going to start again, but I don't think I'm going to. All right, let's take this. Greater than 4. Start writing 1, 2, 3, 4. That's what happens when you're doing too many things. Greater than 4. So we know this is 5, and we know this is 6. The complement then would be 1, 2, 3, and 4. You probably caught that before I did. All right, then it says find the probability. They have nothing in common. Find the probability of A. A has 2 out of our 6, which is 1/3. The probability of B, which is also the probability of A prime, which is the complement, is going to be 4 out of 6, which is 2/3. So what is true about the sum of the probability of A plus the probability of B? So the probability of an event occurring plus the probability of its complement occurring will always equal 1. And we're going to forget about this. It will take too long, and I don't think there's a lot of merit in doing that. So, but with that, we're just going to move on to exercises 4 and 5 quickly so we can finish with this recording. I feel like the reading takes more time than anything. Answer each of the following problems. If the probability I will draw a red marble from a bag is 3 out of 17. So the probability of a red marble is 3 out of 17. What is the probability I won't draw a red marble? So the probability of not a red marble is going to equal 1 minus, so I know it's going to be 1 minus 3 out of 17. And when you can do this in your calculator, but this is how you do it by hand. We change the 1 to the 17 over 17, the same denominator, and you get 14 over 17. If the probability that it's going to rain tomorrow is 20%, now again, I just change it directly to a decimal. What is the probability that it's not going to rain? That squiggle means kind of not. That's notation. But you could write the words out, not going to rain. So you know that's going to have to be 0.80. but because it gave us in a, I'm sorry, yeah, 0.080. Oh, Lord. Okay, it's just been one of those days. So we're going to give it back to them in a percentage, 80%. All right, now here's the last one. In theoretical probability calculations, the set that makes up the sample spaces can get difficult to write out. It's good to remember that things like tree diagrams can help. All right, so they'll never tell, well, I shouldn't say that. They have had times where they told you to draw the tree diagram, so I'm not going to say they never do. So two four-sided die. So two four-sided die are rolled and the number on each is noted. So draw a tree diagram. So remember, so our first experiment is we're going to roll a four-sided die. So what are our outcomes? We can get a 1, a 2, a 3, or a 4. Then we have our second experiment, which is rolling the four-sided die another time, or a second one. And our possibilities are 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so now if you're the kind of person that would rather write this out, because one of my students just said, oh, I like that better, you can spend a little time and say 1, 1, 1, 2, 1, 3, 1, 4, and so on. So you get this when you're all said and done. All right, so then what is the probability that you don't get two of the same number? So that you don't get, so maybe it's easy to figure out which when you do get the same number. So I get the same number here, 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 and here. So the probability I get the same number is going to be 4 out of, okay, we have 4 times 4, which is 16, or you can add them all up. So 4 out of 16, but remember, they want the probability of not the same numbers. Which is going to be 1 minus 4 over 16, which is equal to 12 over 16. Or if you find the need to have to reduce it, you can reduce it by 4 and get 3/4. So this video ran a little longer than I would have liked, but like I said, I feel like between my silly mistakes and the reading that had to take place, I feel like it took a little longer, but not hard. Probability is the easiest unit, which is great that it's towards the end. So it gives us a little bit of a relief from some of the other stuff we've done. So until next time, always make good choices and be safe.